Alright, let's tackle this integral estimation problem together. So we are given an integral I, which is the integral from 0 to 1 of 2x over 1 plus x squared dx. And we are going to estimate this integral using something called Simpson's 1/3 rule, specifically with a grid value or step size h equal to 0.5. The core question here is to find the difference between our estimated value of I and the exact value of I. We need to figure out which of these options that difference is closest to. Is it 10.007? Is it 20.001? Is it 30.007? Or is it 4 minus 0.005? To solve this, we'll break it down into a few key steps. First, we need to calculate the precise exact value of the integral I. Second, we'll apply Simpson's 1/3 rule to estimate the integral using the given information. And finally, we'll calculate the difference between our estimated value and the exact value, and then compare that difference to the given options to find the closest one. Let's start with the exact value. Our integral is I, which is the integral from 0 to 1 of 2x over 1 plus x squared dx. To evaluate this, we can use a substitution method. Let's let u equal 1 plus x squared. If u is 1 plus x squared, then du is equal to the derivative of 1 plus x squared times dx, which gives us 2x dx, which gives us 2x dx. That's handy because we have 2x dx. That's handy because we have 2x dx right there in our integral. Now when we do a substitution like this, we also need to change the limits of integration. Equals 0. Our new lower limit for u will be 1 plus 0 squared, which is just 1. And when x equals 1, our new upper limit for u will be 1 plus 1 squared, which is 1 plus 1, giving us 2. So with our substitution and new limits, the integral transforms into the integral from 1 to 2 of 1 over u du. Now let's evaluate this. The integral of 1 over u is the natural log of the absolute value of u. We need to evaluate this from 1 to 2. This gives us the natural log of the absolute value of 2, which is just the natural log of 2, which is just the natural log of 2 minus the natural log of the absolute value of 1. Since the natural log of 1, which is the natural log of 1, since the natural log of 1 is 0, the exact value of our integral I exact is the natural log of 2. If we use an approximation for the natural log of 2, it's approximately 0.69. Okay, now for the estimation part using Simpson's 1/3 rule. The general formula for estimating the integral from a to b of fx dx using this rule with n subintervals, where n must be even and a step size h equal to the quantity b minus a divided by n, looks like this. I estimated is h over 3 times the quantity f of x0 plus 4 times f of x1 plus 2 times f of x2. And this pattern continues alternating the coefficients 4 and 2 until we get to 4 times f of x2. And this pattern continues alternating the coefficients 4 and briny sum going plus f of xn. Let's apply this to our specific problem. We are given that a is 0, b is 1 and h is 0.5. The number of subintervals n is calculated as b minus a divided by h, which is the quantity f of x1. f of x1 minus 0 divided by 0.5. That gives us 1 divided by 0.5, which equals 2. Since n equals 2, which is even, we can use the simplified Simpson's rule formula for just 2 subintervals. I estimated is h over 3 times the quantity f of x0 plus 4 times 1 minus 0 plus f of x2. Our function fx is 2x over 1 plus x squared. Next, we need to figure out our grid points, the values of x0, x1 and x2. x0 is our starting point a, which is 0. x1 is x0 plus h, so that's 0 plus 0.5, giving us 0.5. x2 is x1 plus h, which is 0.5, plus 0.5, giving us 1.0. Notice that x2 is our endpoint 0. Notice that x2 is our endpoint b, which is correct. Now let's calculate the function value fx at each of these points. Value fx at each of these points evoke 0.5, giving us 0.5. 0 squared, that's 0 over 1, which is just 0. f of x1 is f of 0.5, which is 2 times 0.5 divided by 1 plus 0.5 squared. That's 1 divided by 1 plus 0.25, so it's 1 over 1.25, which is equal to 0.8. f of x2 is f of 1, which is 2 times 1 divided by 1 plus 1 squared. That's 2 divided by 1 plus 1, which is 2 over 2 over 1. Now we substitute these values back into our simplified Simpson's rule formula. I estimated is 0.5 divided by 3 times the quantity f of x 0 plus 4 times f of x 1 plus f of x2. Plugging in the values we just calculated, I estimated is 0.5 divided by 3 times the quantity 0 plus 4 times 0.8 plus 1. Calculating inside the bracket 0 plus 4 times 0.8 is 3.2. which equals 4.2. So our estimated is 0.5 divided by 3 times 4.2. 0.5 times 4.2 is 2.1. So we have 2.1 divided by 3, and 2.1 divided by 3 is 0.7. So our estimated value of the integral is 0.7. Now let's calculate the difference between our estimated value and the exact value I estimated minus I exact. That's 0.7 minus the natural log of 2. Using the more precise approximate value for the natural log of 2, which is about 0.693147, we calculate the difference is approximately 0.7 minus 0.693147. Performing that subtraction gives us a difference of approximately 0.0653. Our calculated difference is approximately 0.006853. Let's look at our options again. Option 1 is 0.007. Option 2 is 0.007. Option 3 is 0.0007. Option 4 is minus 0.005. Comparing our difference 0.006853 to these options, it is clearly closest to 0.007. The difference between the estimated integral value and the exact integral value I estimated minus I exact is approximately 0.006853, which is closest to 0.007. So the final answer is 0.007.